Welcome back to Godot 101. In this video, we're going to explore how to create basic arcade physics for things like platformers using the KinematicBody2D node type. So we're starting with a new project, and I've created a new empty scene, and we're going to add a node to it. And the node we're going to use, if you recall, we've talked before about the different collision objects, and we used Area 2D in the previous examples. And for this one, we want to use one of these three physics body 2Ds. And specifically, we're going to use the kinematic body. And this is the one with the little Space Invader icon, because this is the one that's used, or best used, for arcade-style physics. You want to run around, you want to bump into things, but you don't necessarily need full-on physics simulation and the overhead that comes with that, right? This is good enough for doing platformers and top-down games and whatever else other kind of games you might think of. So we're going to make a kinematic body 2D, and that's going to be the player. And that's going to need a couple nodes underneath it. One is going to be a sprite, so we have something to look at. And the other one is going to be our collision shape, because we're going to need that as well. Now for the sprite, I've chosen some art from this project that I got from OpenGameArt, and I'll link in the description below where you can go get it too. But it comes with some different images of the player. And so it's this little red-haired boy, and it has some different animations for running and jumping and so forth. And we'll talk about how to use those later. But for right now, we're just going to use this idle frame. And I'm going to drop that in the texture. I'm going to rename these to sprite and this one to collision. And then we just need to make our collision shape. But before we do that, you might have noticed how enormous this sprite is, right? This blue or purple rectangle is our screen. And so he doesn't even fit on the screen, right? He's too tall. This character is about 500 by 700. Really nice, super high resolution that you can use in, all sorts of games, but it's way too big for our purposes here for sure. So we definitely want to resize that. So I'm going to go to the sprite, and I'm just going to change the scale to about 20%, 0.2. And that's going to give us a much more manageable size for this guy, so he can run around the screen. And then we just need to make our collision shape. Now we have some decisions here on what kind of collision shape we want to use, right? There's a lot of options. Rectangle is definitely one of the most common ones, but there's also other options. Now, depending on how you want to make things, you can do this in a lot of different ways. You could make a small rectangle that's just covering the feet area, so that that's the part that lands on the ground and collides with things. You could do a lot of other things. I'm going to use the capsule shape. This is a very common one to use for this style of character. You see it's called a capsule shape because it's basically an elongated round shape with a round ends. So we just use the handles here to resize it, right? So we're going to stretch it out to the size we want, and then we're going to grab the sides, which also, we should have grabbed the side first, and we bring that back down. And we just want this to cover the main area of the player. And this is going to make us stop when we land on the ground. It's going to make us stop when we bump into a wall. And it covers the shape pretty well, or it covers the sprite pretty well. So let's just save this player scene, and we're ready to start talking about how to make it move around. So we're going to add a script and create. So when you're using a physics body, it is recommended in the documentation that you use the fixed process. You set that to true, and that you do all of your movement and collision code and everything like that in the fixed process function. That's because the fixed process function runs at a fixed frame rate, delta should always be the same, 1/60th of a second, and all of the physics calculation happens in that time frame. So your code will be synced up and you won't have any, hopefully, physics errors or glitches happen. When you're moving a physics body, you don't just change it. You don't use set pos. You don't set its position like we did with the area. And that's because it needs to do the physics calculation to see when it moves if it runs into something. So instead you use the move function. And in the move function you put how far you want it to move, right? Typically that's going to be your velocity, right? And we'll have a variable for that. Let's go ahead and set that up, vel for velocity. And that's going to be a vector2. And I usually like to have characters that don't, instantly start moving when you press the key and then instantly stop. I like to have some sort of acceleration. So we're also going to have an acceleration vector that is going to be what we apply our motion to, and it's going to affect the velocity. So when we press a key, we're going to accelerate in the direction we pressed. Okay, and how much we do that, well, that can vary. So in the move function, we're just going to put velocity times delta. So move it whatever your speed is times the time step. And then we need to set our acceleration by pressing the keys. We're also going to set up a couple of constants for how we want this to function. For example, the acceleration when we press a key, how fast do we speed up to our running speed? And for that matter, we're going to have a max speed. And this is the maximum speed that the player will run at. Pixels per second in all of these. And we're also going to have a friction. And that's going to be how quickly you slow down. Okay? All of these can be adjusted to give you a wide range of behavior, how your movement works. But we're going to stick with that right now. So in our fixed process, our acceleration, because we're going to use the left and right arrow keys to run side to side. So we're talking about the X direction. And we're just going to use the input is action pressed UI right minus is action pressed UI left. Right? This is going to give us a 1 or 0 minus a 1 or 0. If you hold down both keys, you're going to have 1 minus 1. That's 0. You won't move if you're pressing them both. If you press right, you'll have 1 minus 0. And if you press left, you will have 0 minus 1, which is perfect because left should be in the negative direction. We just want to take that acceleration and multiply it by our constant so it will be of the right magnitude. Next, our velocity is just going to, going to add the acceleration times the time step. So our velocity will increase if we're holding it down. But if we do that, we're going to keep accelerating as long as we hold the button down, and our speed will get higher and higher and higher. So we want to make sure we keep it at the max speed. So to do that, we're going to take the x velocity and clamp it. And the clamp function just lets us set a maximum and minimum value for that parameter. So for the velocity x, we want to set it to the minimum should be negative max speed, and the maximum should be positive max speed. That way it will never get above 500 in either direction. And then we can move. And if you try this out, you will see that you can run to the left and the right by holding down the arrow keys. But of course, you don't stop, right? When you let go of the key, you keep going. And so we need to have the character stop when you let go of the key. And that's what our friction is for. So what we're going to do is we're basically just going to check if our acceleration in the x direction is 0, so we are not pressing the keys down, right? then we're going to apply friction. So the acceleration is going to be whatever the velocity is times friction times delta. Oops. And so if we're not pressing the keys down, then there's going to be friction is negative. So we'll be multiplying by a negative number, so it'll be in the opposite direction of whatever direction we're traveling. And that's going to let the player coast to a stop, right? So when I let go, he stops. Okay. And I set friction fairly high, so he stops pretty fast. Right? If you make the friction a little lower, it'll feel like you're kind of on an icy surface and it's very slippery. But we don't want that. Now we need some gravity, but we don't want to just put it in now because we'll just fall off the bottom of the screen. We need something to land on. So we're going to make a platform. So I'm going to make a new scene. And the platform is going to be also a physics body. But because the platform doesn't need to move, instead of using kinematic body, we can use static body. And static bodies are special physics bodies that are just set up to be stationary. So they don't include any code for moving it around. So they're simpler. They just need to sit in a spot and stop things when they run into them. So we're going to use that for our platform. And the platform also needs a sprite, and it also needs a collision shape. Now the sprite I'm going to use, just to keep things simple right now, is I just have a plain green square. Okay, plain green square that just will be whatever size we want it to be. And let's rename these. And then we can use the sprite scale to set this whatever size we want. So let's set the scale to, let's say 200 wide. Nope, I want to multiply it by, let's say 20. Yeah, okay. So that's going to be my platform. In the collision shape, we're just going to use a rectangle. And we'll just set the extents of that rectangle to be the extents of our sprite, so it looks like a solid thing. Okay, save that, and that will be our platform. So we'll go back over to our main scene, and we'll put a instance of the player. Oops, you have to click on the node. We'll put an instance of the player in there, and we'll put an instance of the platform in there. Okay, just going to put the platform in towards the bottom of the screen, and we'll have the player spawn up here in the middle of the air. And now we can add some gravity to the player. So we'll set a constant for how strong we want our gravity to be. Bigger this number, the faster they will fall. It's positive because we want it to go downwards. And gravity is going to affect our y acceleration. So right here we can just say acceleration.y equals gravity. And that's it, because we're going to apply the acceleration to our velocity, and we're going to move at our velocity. So let's hit run on our main scene, and you will see you instantly fall down. But now you're going to notice a problem. I'm pressing the arrow keys. I can't move. So I fell down and I stopped on the platform, but now I can't walk anymore. So what's going on? Well, we need to talk a little bit about how the kinematic body collision works. So let's look at this example diagram. So right now when we're moving, we have our start position, and we have two forces acting on us: gravity, which is pulling downwards, and pressing the arrow key, which is pushing us to the right. So our velocity vector is going to be at an angle, something like this. So when we move, we should move from this position to this position. And that's what happens when we're falling. But when there's a platform in the middle, what happens is we can only move this far. Right? We can't move the full distance we want to move. As soon as a collision happens, the object will stop moving. So as soon as it detects colliding, and that's detected by a function called isColliding. So isColliding becomes true as soon as the object collides with another object. So we've moved to here and we've stopped. But there's still some remaining movement left that isn't happening. And the problem becomes when we're standing on the platform, we still have gravity pulling us downwards. And when we press the arrow key to the right, that means our desired move is still a diagonal like this. Well, it can't move diagonally like this. It instantly detects a collision, isColliding is true, and stops moving. That's why we can't move right now, even when we press the arrow key, because we're trying to move down into the platform because gravity is always pulling us down. So the way that we fix that is by using something called the collision normal. This is the collision normal. A normal is a vector of length 1. That's why it's called normal, because it's normalized. And it's perpendicular to the surface of whatever you collide with. So for example, of the ground, this would be the collision normal, 0, -1. If we ran into a wall, the collision normal would be pointing right or left in the x direction. So what we want to do is take that remaining unused movement and slide it perpendicularly to the collision normal. So that way if we're moving diagonally, we would hit and slide along. And if we're standing on the platform, we will slide along it to the right when we try and move. And we won't try and go down into it. Okay, so that's what we're going to do in our code. So this move function, where we tell our body how far we want it to move, if it collides, it will return that unused portion of the movement vector. So we're going to save that in a variable called motion. And so this is the remaining motion that we didn't get to do because we hit something. And so normally, if you're in free space, that would be 0, 0 because we were able to move the full amount. But if we hit something, that will have some vector in it. So now we're going to say if we are colliding, if isColliding is true, then we need to get the collision normal. So we can find out what that is. We'll just call it n. So get collision normal. Now we'll have that normal, which since we hit the ground, we hit the platform, is going to be 0, -1. And then we're going to take motion and set it equal to the motion vector slid along the collision normal in .slide motion. And now that we have that remaining motion vector pointing in the slide direction, we can move again by that vector. And now we'll be able to move, but you're going to notice two things. One is it's a little choppy. There's something going on. And watch what happens when I run off the edge. Whoa, did you see that? It almost teleported. It fell so fast. Why did it fall so fast? Well, our velocity vector is still pointing downwards even though we hit the ground. And gravity is making it point more and more downwards. And so our velocity vector is getting really large the longer we stand on the ground. So as soon as we fall off, we're suddenly going to shoot downwards really fast. So we're going to fix that by doing the same thing that we did with motion and sliding the velocity as well. And what that'll do is let us run along the ground, and when we fall, we will start falling from a 0 y velocity and start accelerating. And that looks a lot better. So that is the basics of the KinematicBody2D. In the next video, we will talk about how to make it jump and also how to animate the sprite so that we can look like we're running instead of just sliding along the ground. All right, thanks for watching, and I'll see you next time.